So hi everyone, welcome to this quiz, and the topic is matter in our surroundings. We are going to be looking at some important and interesting questions on this topic. So make sure you watch the entire quiz, and I'm going to make the concepts really easy for you. So are you guys excited for this quiz? Hi, I see a lot of folks are out here. So hi Dhruv Gupta, hi Aryan Gupta, hi Arya, hi Yash Gaming, hi Crazy Grammar. Alright, welcome to this quiz. And guys, if you haven't checked out our website, manochaacademy.com, do check it out. I'll put the links below. And we have these courses for physics for class 10 and class 9 and also the class 9 ICSE board. So do check out our courses. We have big discounts going on right now, and you can check it on our website, manochaacademy.com. Hello everyone, and if you haven't hit the subscribe button for our channel Manocha Academy, hit the subscribe button right now. And guys, don't forget to click on the notification bell so that you get notified about our live classes and new videos that we upload. So I'm trying to take live classes daily at 8 p.m. So do check it out and do share it with your friends so that we can have more people on these classes. Hello, good evening everyone. Sorry if I can't take everyone's name out here. So hi Rajiv Joseph, hi Ostvinayak, hi Srinivas, hi Govardhan Giri, hi Gangster Aritra. Okay, hi everyone. And so are you ready for this quiz? Let's dive right into it. So here's our first question, guys. Matter has A, mass, B, volume, C, weight, or is it D, all of these? So guys, what do you think is the answer of this first question? So very good. I'm seeing a lot of answers here. So the right answer is it's D, all of these, right? Excellent. So because you know that matter has mass and it occupies space, which means it has volume, right? So volume means it occupies space. And we know that if something has mass, it'll also have weight, right? So because we know weight is mass into acceleration due to gravity. So the correct answer, very good. I see a lot of you have the right answer here, D. So the answer is going to be matter has mass, volume and weight, and it's all of these. Excellent. Now let's go on to our second question, which is dissolving sugar in water does not increase the level of water because particles of matter A are very, very small, B have spaces between them, C are continuously moving, or is it D, they attract each other? So take a look at this question, guys, and what do you think is the answer here? Okay, so here's our second question for you. So very good. The first question, I think a lot of people got right. Now go ahead and try the next question, which is that when you dissolve sugar in water, it does not increase the level of water because particles of matter are A, very, very small, or is it B, have spaces between them, C, are continuously moving, or is it D, they attract each other? So excellent. I see a lot of you are interactive here and you're writing out the answers. That's great to see. So all of you guys, please try here. And so what does this question mean? That let's say the level of water is here, right? So before you put the sugar, the level is at this level where I've shown it with the arrow. Now once you put the sugar and stir it with the spoon and dissolve it and remove the spoon, we notice that the level of water, it does not increase. That means the level of water remains the same here. Now why is that? Okay. And excellent. I see a lot of you have written the correct answer. It is because particles of matter have spaces between them. So let's try to understand what this means. So when you consider water here, so let's say these are the water particles that I'm drawing, or water molecules, right? So these are all the tiny, tiny water particles. And when the sugar particles, which I'm going to show in pink color here. So let's say when you put, or let me use white, right? The color of sugar. So when you put the sugar particles and you dissolve it, right? The sugar grain is going to break up into tiny, tiny particles, and I've drawn them a little bit bigger than the water molecules. It's going to go and fill in the space here. So these white particles that you see are the sugar particles, and the blue particles are the water particles. And because sugar is occupying the space between the water particles, the level of water does not increase. Okay, because it goes and occupies the space, there's space between the particles of water, and sugar takes that space, and that is why the correct answer, excellent, I see a lot of you got it, that's really good. It's because this experiment shows us that particles of matter have space between them. Very good. Now let's take a look at our next question. Which one of the following is not considered a state of matter? Is it A, solid, B, liquid, or is it C, gas, or D, solution? So guys, what do you think is the answer for this question? So try the third question here. So what do you think is the answer here, guys? Which one of the following is not a state of matter, right? So I think you guys must be knowing that the three important states of matter are solid, liquid, and gas, right? So all of these are states of matter. And what does a solution mean? Solution, you know, it contains a solvent and a solute and a solvent, right? So when you dissolve a solute in a solvent, and a good example of that is, because there can be solutions of different types, but let's say you dissolve salt and water. So that's where you're mixing the solid salt in water, right? So here there are two states involved, and solution is not considered a separate state of matter, right? Because if you look at salt, there's the solid, and then you have water, which is liquid here. So there are two states in a solution, right? Solid and liquid. And so we don't consider it as a separate state of matter. So excellent. The right answer, you guys got it. Superb. It is D. The answer, solution is not considered a separate state of matter. Very good. So now let's take a look at our next question over here, which states that I could not break the table by hitting it with my hand. So let me show you this video, and what does this indicate? So let's go ahead and try to play this video here. Or can I break this table? Ow, looks like my hand is broken. Okay guys, you saw that video. So what I was doing there, I was trying to hit the table, right? And I was unsuccessful in breaking that table with my hand, right? So what do you think is the answer here? Is it, let me just close that. So what do you think is the answer for this one? That I could not break the table with my hand because the particles of matter are very, very small. They have space between them. Or is it C, they are continuously moving, or D, they attract each other? Okay. So guys, when you saw that video, I was with my hand, I was trying to hit that table and I was unsuccessful in breaking it. I'm not Superman, right? I couldn't break that table. And so what is the answer here? Superb. I see a lot of you got the right answer. You guys rock. The correct answer is D. They attract each other. Okay. Because if we consider the particles of wood, right, in the table here, right? So let's say those are all the particles. So let me draw them here. So these are all the particles of wood, and we know that there is a very strong force. Okay. So there is a very strong force between the particles. This is called the interparticle force, because particles of matter, they attract each other. And you know that in a solid, it's really strong. So you need a really big force to break this table, right? And so this shows that particles of matter attract each other. And in a table and in a solid, we know the force is the largest. So excellent. A lot of you got the right answer. Very good. Now let's move on to our next question. A rubber band shape can be changed by stretching it. So as you can see in the picture here, I'm stretching the rubber band, right? So the rubber band is A, a solid, or is it B, a liquid? Is it C, gas, or is it D, plasma? So guys, what do you think is the answer here? Okay, so go ahead and try this question, right? So here we're asking, what state of matter is the rubber band? Solid, liquid, gas, or plasma? So I'm seeing a lot of A's there. I think there's some D's. What do you think is the answer? So we definitely know the rubber band is not a gas, right? So rubber band is not a gas, and liquid, a good example is water. So certainly rubber band is not a liquid, okay? And plasma and Bose-Einstein condensate, they are special states of matter, right? So I won't be discussing those in detail here. I would encourage you to, you can check on the internet and see what these really mean. So there are these 5 states of matter, right? So plasma, and there's another guy called Bose-Einstein condensate. So this is our 5th state of matter. So maybe we can make it an option E here. Okay, BEC in short. So what do you think is the answer here? Very good. The rubber band is a solid. Okay, even though we can change the shape by stretching it, rubber band is a solid. Why? Because so what I'm doing here, I'm applying a force on the rubber band, right? I'm stretching it. But once this force is removed, what will happen? The rubber band will quickly gain back its original shape. Okay, so the rubber band is a solid, and many times we call this as an elastic solid. Okay, so the rubber band is considered an elastic solid, and so that's the right answer here. Okay, very good. Now guys, let's take a look at our next question. The shape of matter which has a fixed volume but no fixed shape, is it A, solid, B, liquid, C, gas, or is it D, none of these? So note the question carefully. We are looking for the state of matter which has a fixed volume but it does not have a fixed shape, right? So guys, what do you think is the answer here? Try this question. Okay, so I know a lot of you are asking me to explain plasma. Maybe I'll make a more, because that's a more detailed topic, so maybe I'll make a video on that. But I would highly encourage you to go to the net and read about what is plasma and what is Bose-Einstein condensate. They're really interesting to know the high level details. You don't need to go into the nitty-gritties of that, but I would really encourage you to check those yourself. Okay, so good. I see a lot of answers here. Excellent. You guys are really interacting in this quiz and trying it out. I'm really loving it. So please take a look at this. Which state of matter has a fixed volume but no fixed shape? Okay, so we know that what is solid. So let's look at our options here. We know that solid has a fixed shape and fixed volume, right? So it can't be a solid because it has a fixed shape and a fixed volume. And what about gas? So gas, we know it has no fixed shape, right? Because the gas takes the shape of the container, and it has no fixed volume because you can easily compress it, or it basically fills up the container, right? So if you put the gas in a small container, it'll take the volume of the small container. If you put it in a large container, it'll take the volume of a large container. So what is the right option left here? So a liquid, you know, it has no fixed shape, right? The liquid has no fixed shape, but it has a fixed volume. So let's understand that. So what does that mean? That you know the volume of a liquid, like for example, when you buy a 1 liter bottle of water, right? So that volume is fixed, right? You can't say that, no, I bought 1 liter, but now it's changed to 900 ml, or it's become 1.1 liter, right? That's not possible. The volume of the liquid is fixed, right? And that's how we measure it, a 1 liter bottle or a 2 liter bottle, right? Or a 500 ml bottle. So the volume is fixed. But you know that the liquid has no fixed shape because it takes the shape of the container. So liquid takes the shape of the container it is put in, right? And what does that mean? If you take a 1 liter water and you put it in a jar like this, it'll look something like this, right? Or if you put it in a flask like this, it's going to change into this shape, right? Or if you put it in a container like this, it's going to take this shape. So look here, I can pour the same 1 liter of water, so the same volume, but the shape is changing based on the shape of the container. So excellent. I see a lot of you have the right answers. Superb. The correct answer is B, liquid. It has a fixed volume but no fixed shape. And note what the solid and gas are here. I have written them down. Very good, guys. Now take a look at this next question. The melting point of ice, is it 0 Kelvin, 273 Kelvin, 0 degree Kelvin, or 273 degree Kelvin? So guys, take a look at this question carefully. So as you can see in this picture, we have some ice here, right? So can you see that solid ice and it's melting? So that's solid ice here and it's melting to liquid water. And we're interested in the melting point. And melting point, you know, is the temperature at which the ice melts, or the temperature at which any substance melts. It's called its melting point. Right? So what is the melting point of ice? So I see a lot of answers here. Some are saying D, B, C. Okay, so there's some confusion here. Look at the options carefully. So we definitely know that the melting point of ice is 0 degrees Celsius, right? I think all of you know that because ice melts at 0 degrees Celsius. But the question is, the unit used here is Kelvin. Can you see, right? So the unit used in this question is Kelvin, which is the SI unit of temperature. Now the important thing is, how do we convert 0 degrees centigrade to Kelvin? Okay, so what is the formula? We know the formula is K equal to 273 plus C. Okay, the temperature in Celsius. And some books might even write 273.15 or 0.16 to be more accurate. But we are going to use 273, the approximate value based on the options. Okay, so now if we fill in the numbers, what are we going to get? 273, and this is plus 0, right? You guys can see here. So the value is 0. So the Kelvin temperature is going to be, in Kelvin, it's going to be 273. So now which option should I choose? Should it be B or D? Okay, so a lot of you are saying B, some of you are saying D. Remember this really important point, and I mentioned this in an earlier class also, that for Kelvin we don't use the degree symbol. Okay, so using the degree symbol is not right. Okay, so degree should not be used for Kelvin. Kelvin, for Celsius we use degree. We write 0 degrees Celsius, or it can be 32 degree Fahrenheit. But for Kelvin, remember, the degree symbol is not used. So the correct answer here is B. Very good. I think some of you got it, some of you thought it's D, but it's okay. Remember this important point. For Kelvin, please don't write degree. It's simply written 273 K, and K with a capital K. Okay, so please remember this really important point. Excellent. Let's move on to our next question. So what does this say? If a perfume bottle is left open, we can get the smell from a distance. Now why is this? Is it due to A, evaporation, B, diffusion, C, condensation, or is it D, evaporation and diffusion? So guys, take a careful look at this question and think practically. Imagine that you have a perfume bottle which is left open in the room, and you know that you'll get a smell at a distance after some time, right? So which option is it due to? What do you think here? Okay, so I'm seeing a lot of different answers here. Some are saying A, B, D. So guys, what do you think is the answer here? So I want all of you to try it. So let's imagine this is a perfume bottle we have here. Okay, I'm not a great artist, but I'll try to draw something here, right? So this is a perfume bottle, and let's say it's left open and it contains some perfume. Okay, so let's say this is the liquid perfume here. You know, right? The perfume in the bottle, you can see the liquid. So this is the liquid perfume, and let's say you're standing somewhere here. So you're at a distance and you can get the smell of the perfume. So you're getting the smell. So what is it due to? Okay, so if you carefully think, the perfume is in a liquid state, right? And there's probably some gas vapor state of the perfume also in the bottle, right? But as the bottle is left open, what's going to happen to the liquid, right? The liquid is also going to start changing to vapor and evaporating, right? So we know that the perfume, so these are the vapors which are coming out, right? It will start evaporating and becoming into a gas state, and this we know starts spreading across the whole room and when it reaches your nose here, right? So when these particles reach your nose, then you'll be able to get the smell of perfume, right? So what is this process known as? And it's going to spread in all the directions. So this process of spreading, we know it's known as diffusion, right? Where the particles are moving on their own. And also, as we discussed, since there was a state change from liquid, the liquid perfume was changing into these gas particles that we've shown here. So definitely there's a state change going on, and that we know the state from liquid to gas, because it's not happening at the boiling point, it's happening at room temperature here. So that is evaporation. Okay guys, so are you following this? So there's clearly there's definitely evaporation going on and diffusion. So the correct answer is evaporation and diffusion. I know many of you wrote just diffusion, that's also right, but note that two things are happening here. So this question is more tricky, and the best answer that we can choose, that two processes happening out here clearly, because the perfume bottle is left in the open. So definitely evaporation will happen, because perfume, you know, is a very volatile liquid. There's this term, right? This guy is very volatile. That means it evaporates easily. It has a low boiling point, right? So it evaporates easily, and we have both evaporation and diffusion going on here. So that's the right answer. Very good. So now let's move on to our next question. Why natural gas is compressed and stored in cylinders, right? So you know that we have these cylinders which contain CNG, right? Compressed natural gas. Okay. So why is it compressed and stored in cylinders? Is it to avoid leaks, or is it to store large volume, or is it to solidify it, or to prevent evaporation? So guys, think carefully here. This practical question, you've seen the CNG cylinders or you've seen LPG cylinders, right? Where you know that the gas is compressed and stored in the cylinders. Now, why do they compress and store it? What do you think is the answer here? So think, what will it be? The first option, to avoid leaks, probably not, right? Because there are better ways to solve it, and you definitely have the cap and all. So I think this won't be a good answer, right? And what about option C? You know that it's in a liquid form. You know it's not solidified, right? So this is also probably not a good answer, right? And to prevent evaporation, we are trying to avoid leaks or prevent evaporation. You can store. But the main question is not just storing in a cylinder. The main question is asking why it is compressed. So definitely we are storing it well in a cylinder to avoid the leaks and prevent evaporation, but that's just part of the question, right? The other part is, why is it compressed? And the reason we compress the gas, right, and stuff it into these cylinders so that we can put in a large volume. Okay, so that's the main goal, because you want to squeeze in as much CNG or as LPG as possible. Of course, you don't want to put so much that the cylinder will burst, right? So they, of course, measure the pressure of the cylinder. So the gas is compressed because, guys, you know that gas occupies, if it's left without being compressed, the gas will occupy a huge volume, right? So to fit it in a smaller volume in a cylinder, we will compress it, right? So we compress it, and it becomes it's compressed so that we can store a larger volume of it, right? And it's also liquefied, right? So like LPG is liquefied petroleum gas. So compressing it allows you to store a larger volume so that you can have more of the gas in the cylinders. So very good. The correct answer here, the practical answer is B, to store large volume. Excellent, guys. Now let's take a look at this question. Force of attraction between the particles is maximum in A, oxygen, or is it B, water, C, chalk, or D, iron? So guys, what do you think is the answer here? So very good. I'm really happy. I'm seeing a lot of answers here in the chat. You guys are really participating well, and please do share it out with your friends. And if you haven't hit the subscribe button, hit it right now and click on the notification bell so that you get to know about our live classes and our videos, right? So what is the option here? Very good. I see a lot of you've got the correct option. It's D, iron. Okay, because we know that oxygen is a gas, right? And we know that the force of attraction, oxygen is a gas. Okay, let me come to that. Water is a liquid. Okay, and these last two guys are solids. And we know that force of attraction is maximum in solids. Force of attraction between the particles, right? That's why the solids have their fixed shape and they're not easy to change the shape of the solid, right? You need to apply a force. So now our comparison is between chalk and iron, right? So if you compare chalk and iron, right? Which one will be the right answer? Definitely iron, because you know that you can easily take chalk and break it, right? I'm sure you've tried this. So if you take a piece of chalk, you can break it easily. This means that the force, even though chalk is a solid, the force of attraction between the particles, so force of attraction between the particles is weak in chalk. But in iron, the force of attraction between particles is strong. Okay, so this is the difference here, that in iron it's strong, and that's why excellent. I see a lot of you've got the right answer, D, iron. Very good. Now let's take a look at the next question. Which state of matter exerts pressure in all directions? Is it A, solid, B, liquid, C, gas, or D, none of these? So what do you think is the answer here? So which state of matter exerts pressure in all the directions? So guys, take a look at the options here. And as you can see, we have pictures here. So for your visualization, this is a solid. This you can see the particles of a liquid, and this is a gas. So guys, what do you think is the right answer here? So what is the question asking? Exerting pressure in all directions. So you know that when you take a solid, it exerts the pressure. So let's say you keep a solid on the table, its weight and pressure is only downwards, right? It exerts its weight and pressure downwards. Now if we consider the liquid, so in liquid, you know, the particles are continuously moving and these particles are bombarding the walls of the container, right? So you can understand that the liquid particles will be hitting here, 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 and here, right? So can you see the liquid is exerting pressure on the walls of the container here, but it doesn't exert an upward pressure. Can you see? It's downwards and on the sides. Now let's come to the gas. So in gas, you know, the molecules are going crazy. They are moving randomly all around, right? The gas, the particles have the highest kinetic energy and they're moving in all the directions in a random motion. So you can imagine, so if this is a closed container here, right? So this is we are taking a closed container and it will be hitting in all the directions. It's randomly, the particles are moving. And so as you can see, these particles are going to be randomly moving in all the directions. So the pressure will be exerted in all the directions here, upwards, downwards. So upwards, downwards, to the left, to the right. So the correct answer here, the pressure exerted in all directions is of a gas. Very good. I see a lot of you got the answer C. You guys rock. Excellent. So always all these science questions, analyze it. Don't jump to the answer. See what are the options here and I'm sure you'll get it right. Now let's take a look at this question. The term fluid refers to, so what are our options here? So they're asking, what does the term fluid mean? Is it A, liquid, B, gas, C, solid and liquid, or is it D, liquid and gas? So guys, what do you think is the answer here? So Manas says we rocked. I agree. You guys are really doing well in the quiz. Great. And do keep revising your chapters and studying, you know. So what do you think is the answer here? So let's first discuss what is the term fluid mean, right? So this term fluid here. So the term fluid means, as you can guess from the name, so the fluid means something that can flow. Okay. And we definitely know water can flow. So what can flow? We can say a liquid can flow, right? So liquids are definitely fluids. And now what do you think? The option B. So A is definitely going to be correct, right? Liquid. But is gas also a fluid or not? Okay. So what do you guys think? So gas is also considered a fluid, because imagine if you open a container of gas, right? So let's say you have this container which has gas in it, and if you open it, the gas is going to just flow out like a liquid. Okay, of course it will flow out in all the directions. The liquid will flow downwards due to gravity. Gas particles move away in all directions, but it's also going to flow like a liquid. So this is an important science term to know, that fluid refers to both liquids and gases. So the word fluid means liquids and gases. Why? Because it means something that can flow. So the correct answer here is going to be option D, not option A only, because liquid is not the only fluid, it's liquid and a gas, right? Very good. And now I have this interesting question for you to solve. Absolute zero, right? The lowest possible temperature in this universe is denoted as 0 Kelvin. So absolute zero is 0 Kelvin, which means it's on the Kelvin scale, and you need to convert 0 Kelvin to the Celsius scale. Okay, so guys, and I want you to try this question yourself, and do let me know your answer by putting it in the comments below. And I promise to read your answers and reply to them as soon as possible. Okay, so I see a lot of good answers in the chat here, so you guys are trying it, but take a careful look at this question, and hint is use the equation that we discussed in this class of how to convert Celsius to Kelvin or Kelvin to Celsius, and try to give me the right answer, and do put it in the comments below. So you need to convert absolute zero, which is a very interesting temperature, because this is the lowest possible temperature in this universe. That's why it's called, as you can see the name, absolute zero. Okay, so it's the coldest or the lowest temperature possible, and the value is 0 Kelvin, right? And you need to convert this to Celsius scale. So you cannot have something like -1 Kelvin or -2 Kelvin. 0 Kelvin is the lowest temperature. And do let me know your answers in the comments below. I look forward to reading your answers. So guys, I hope you enjoyed this quiz. And as I mentioned before, we have this website, manochaacademy.com. So do check it out, and you can use this website. It's like a web app. You can use it on your phone, on your laptops, on your tablets. It's just designed like an app. It has the feel of an app, and we have all these courses for you out there for physics, and we are also going to be putting chemistry and math courses, and we have great discounts going on. So do check it out. It's in the links below, and as I said, I'll be taking more live classes. So do subscribe to our YouTube channel, Manocha Academy, and hit the notification bell. And guys, hit the like button for this video if you haven't, for this class, and do share it out with your friends, because we want more people joining in, and so that the Manocha Academy family becomes larger. And thanks a lot for your support and feedback that I keep reading on our YouTube channel. So great, and do let me know to the answer for this question that I gave you, right? So do try it and write it in the comments below. All right guys, take care. Hope you enjoyed the session. And when is the next live class? So I usually put the notification around 5 or 6 p.m. So maybe it'll be tomorrow or Monday. You'll get to know, because usually on the weekends I'm not having the live classes. But if you click the notification bell, you'll get to know it. You'll be notified, and you can check around 5 or 6 p.m. because we are having these live classes daily at 8 p.m. right? So the time is pretty much fixed, and the live classes are on physics, chemistry and maths topics for class 9 and 10, but they are also very useful for class 7 and 8 also. So guys, do share it out with your friends so that we can have more folks on this live session. And thanks a lot. You guys were very interactive. I thoroughly enjoyed it. I saw so many answers, and you guys really did well. Awesome. Take care, everyone. Bye. All right, guys, take care. See you in the next live class. Bye-bye.